Welcome to Ask and Learn.
We have an aluminum rod which has a resistance of 1.23 ohms at a room temperature and also has a coefficient alpha. And we need to find what the resistance of this aluminum rod will be whenever it's at a temperature of 120 degrees Celsius. So we're going to start by writing an equation for the resistivity whenever there's a change in temperature. So this resistivity rho is going to be equal to rho naught times 1 plus alpha times a temperature T minus T naught. And we're also going to do this for the length of the wire. So this length is equal to L naught times 1 plus alpha times T minus T naught. And we can also do the same thing for the cross-sectional area. So this cross-sectional area A is equal to A naught times 1 plus alpha times T minus T naught. And this is going to be squared. So now the initial resistance R naught, we can find this by multiplying rho naught times L naught divided by A naught. And the final resistance, what we're trying to find, this is just equal to rho times L divided by A. So what we're going to do is we're going to rewrite this R here, and we're going to say that R is equal, and we're going to substitute in a new value for rho. So we see that this expression here is equal to rho. So we're going to plug in that value here for rho. So now this is going to be equal to rho naught times 1 plus alpha times T minus T naught. And then we're going to do the same thing for this length. So this is going to be times L naught times 1 plus alpha times T minus T naught. And then we do the same thing for the area. So we have A naught times 1 plus alpha times T minus T naught squared. And we're going to simplify this. So we get that R is equal to rho naught times L naught divided by A naught, all multiplied by 1 plus alpha times T minus T naught divided by 1 plus alpha times T minus T naught. And now this term here is just going to be equal to R naught. So again, we rewrite this as R is equal to R naught times this expression. So we now have the equation that we need to calculate the resistance R. And keep in mind that this alpha here in the numerator is the temperature coefficient of resistivity. So that value of alpha, so I'm going to call this value alpha prime. So this is alpha prime. and alpha prime, this is going to be equal to 3.9 times 10 to the negative 3 per Celsius. So now we plug in R naught, and then we multiply it by 1 plus alpha prime times 120 degrees Celsius minus 20 degrees Celsius. And then divided by 1 plus alpha, multiplied by 100 degrees Celsius minus 20 degrees Celsius. And then doing the calculations, we'll get a resistance of 1.71 ohms at 120 degrees Celsius.